Hello everyone, welcome to my YouTube channel and welcome to this video. On today's video we're gonna talk about just a little bit of threat hunting, especially how to detect some suspicious behavior with Wireshark, suspicious command and control servers. I also will comment with you guys about threat hunting with network pivoting, and not about pivoting from head chain, or pen testing. It's not like this, but OSINT pivoting and detecting and mapping malicious infrastructure with VirusTotal Threat Graph. First things first, I'm sorry if my English is not that good because I'm not a native English speaker. I work with cyber threat intelligence and threat hunting. I also perform threat researches. I'll simulate command and control communication with this Windows host here, and I'll analyze it with Wireshark and explain more. And in the end, I'll tell you guys about detection rules too, because I work with detection engineer sometimes. So first things first, let's download Golang. So we can perform this with sudo. No needed sudo here. apt install Golang Go. Yes, I'll put it on documents and create folder and C2 to be easier, And here, let's open a terminal inside here. And okay, I'll open Havoc link here. So the first command is this. It isn't hard to download Havoc, I'll do the step by step here. Kali and Debian. It's the longest comment inside this page. I mean, okay, for for Debian and Kali, we use this giant command here. And okay, it's downloading. It takes something like 2 minutes to download everything. And now let's build the Team server. So type cd Team server, and now we're gonna copy these commands here. It's pretty simple. I'll copy this command too. Don't take care about this mistake here or this error message. It isn't an error, so you can simply continue the installation. And now let's make the Team server ts build. Let's continue with the installation. Let's put the command here. Okay, the server debug is okay, and we can type Ctrl+C here. It's just okay. And now we're gonna make the client build. We're gonna type cd profiles and Havoc. Okay, ls. Okay, catch Havoc EOTL. And here we can see the configurations, the default users, the host, and the port. And okay, now let's type the command again. Not this. Here. Okay, the server is running. Let's open the new session here. Sudo su root. Let's where we are. Okay, cd havoc /havoc and client. Okay, as we saw previously, we have the user spider. Just click new profile, create a new profile. The name is gonna be Kali, and the user is gonna be Neo, and the password is the same. Okay, we're in. Let's go here in view, listeners, and add listener, agent, listener. Okay, now we're cool. My IP address, efconfig. Okay, yeah, that's my IP address, 10.0.2.15. And okay, let's create the payload Okay, so payload, agent listener, it's already selected because it's the only listener we have here. Here you can just for student purposes, you didn't need to change anything here. Okay, just select and generate the payload, and it's gonna be compiling the code. Okay, the payload is ready to save. So here you need to choose the location. I'll select on my computer, on home, on my username, and I'll put it on, I don't know, documents. No, not documents. Downloads. Here you can change your payload name, but you don't need if you don't want. But I'll put something random here. I don't know, Adobe. I don't know why, but that's it. Adobe. And okay, remember this path. On my case, it's download and Adobe. The directory we saved our payload, and it's in my case on downloads. Open folder. Here the Adobe HZ or XE, and let's open a terminal here. And we're gonna set up a Python server, a simple Python server. So type Python 3 -m and http server and recall. Now it's listening on port 8000, 192.168.4730, and the port is the same. Okay, and okay, let's go. Adobe. We're gonna keep and open the file. Here the connection was established, and we're gonna interact. We're gonna explore and interaction. Let's view the graph session here. Here we are on a real activity, searching for command and control communication inside our victim's host. I'll suppose that you already know the command and control IP. Okay, so you can search by filters, IP.address and equals and the IP. Okay, and then we can analyze the connections between our command and control server and the victim's host. So first things first, when we're talking about command and control, we need to talk what we call heartbeat connections, or simply beacons. Beacons, it's simply some connection package that our malware sent to the command and control server. It's like he was saying, okay, I'm here waiting for comments. Okay, I'm here waiting for comments. Okay, I'm here waiting for comments. These heartbeats, or these beacon connections, has some default times like 1 second, 5 seconds, 10 seconds, or even higher and higher, you know. Even higher time connections, it's easy to bypass some CN or EDR, you know. I'll not talk about in this video about jitter, and it's a process to turn these connections not default anymore, and it's a defense evasion mechanism, if I can say this, from CNs already. Okay, we have some connections which looks like beacons here. Our command and control server, it's if I come here in view and go to table, it's unresponsive. That's because our server isn't HTTPS and don't have a certificate. But when we establish a command and control with HTTPS and a real certificate, these connections gonna be here for a long time. So I'm just simulating a malicious connections. Okay. So the beacons connections have the almost the same length, and occurs in a period of time, so like 5 seconds. The first one to analyze the TLS certificates. Our machine is on 10.02.15 and the attacker host is on this IP. So as you can see, there's a lot of egg connections. Almost every one egg connections here with the same length. So here our first TLS 1.3 connection I observed here, and that's it. So these fingerprints is a process of client hello, and we just simply analyze him right now. I don't know if here maybe, and in this case we discovered some JF4 and JA3 fingerprints on a real world. When you're working as an analyst, these two indicators of compromise is important to determine if some browser, JA3, or simply is just a malware fingerprint, and that's the first indicator of compromise we have here. So we have others, server hello, and so this is from server side. One thing you need to analyze is the user agents. Let's pick up this over here. So one of the most important indicator of compromise from a command and control malicious connection is the user agents. When we analyze this connection here, the user agent simply comes HTTP 1.0 connection to 200 status, okay, and the server is just simple HTTP 0.6 Python. Of course, our server, I'm running on a Python server, and in the real world, some threat actors can do the same tactics. When we saw some strange parameters inside the user agents, is one of our most important indicator of compromise, So can be curl, can be Python, can be an old version of some browser, and these user agents can be with some missed parameters, like this. It's it's very, very strange, this parameter here. So let's close this. Let's analyze another one. Oh, here it's the file we downloaded. What I was saying about user agents, it was like this: Mozilla 5.0, Windows, and Apple WebKit, Safari, etc., etc. And here we can see the URL, and the URL was exactly this, where the user downloaded the file. Okay, see, right here we can see another HTTP connection, and here we can see the parameters like Python again, and this here MS-DOS program isn't a good signal. Can indicate that the attacker is trying to execute some commands inside the victim's host. For now, it's it. I come soon with when we try to pivot this IP and discover more connections, more details about infrastructure. One of the tools that I like most is VirusTotal Threat Graph. I'll show you guys a real case I was involved weeks ago. This graph that I'll show you guys right now is from one of the possible new IPs from Plump Spiders. Plump Spiders is a Brazilian threat which targets Brazilian banks. We have other spiders which operates inside Brazil only, like Samba Spiders and Samba Spider, and Odyssey Spider. On that threat scenario, we have other spiders like Blind Spider, which is known as Blind Eagle, or the APT C36, which is a LATAM APT group. I performed this pivot a few weeks ago, like a month ago, and the IP was this 24.152.36.138, and I was choosing the malicious behavior, the malicious file, the malicious domains, As we can see here, is one of the properties of the most common controls nowadays. Like, it's the DGA. DGA is like a domain generation algorithm which changes the domain to evade the defenses inside CNs, for example. And we can see the handle numbers and the domain, like the DNS, is one of the common control behaviors I couldn't show you inside the VM host. That's one of my pivots. Following this, we have another Plump Spider IOC, which I'll share with you. It's this IP over here, categorized as malicious by some tools. When we pivoting, we want to discover domain names, URLs, SSL, TLS certificates, fingerprints, network fingerprints, like SSL fingerprints, sorry, like J4, J3. I like to analyzing threat graph, VirusTotal. It's a tool. You just need to create your account and put your company email, okay? So first things first, we have our IP here. Let's start by the first. So malicious connections, like this. You can see the head circle right here, and the first domain looks like being from a shop or maybe an e-commerce. I would not recommend you to connect. The IP address from this one subdomain. Let's put this guy over here. Double click on it to reveal more informations. Okay, there's some resolution here, and the subdomain. So, okay, let's pick up this domain here and search for this guy here. Bonfim the shop, bon the fin shop, okay. Nothing important right here. Plump spiders operate with some tools like we have previously knowledge, like XWARM and Quasarwat. Like, apparently it's the case here. This is simply the base of threat graph usage, you know. From these, if you had time, you can perform a very good analysis about one IP and determine his infrastructure. So when we study the threat, we can understand a lot of things. So inside Brazil, Plump spiders, since 2023, I think, he was operating the soft-adder VPN, and after they connect to the victim's host, they perform some RMM softwares like AnyDesk and TeamViewer. You can simply search in Google for Plump spiders if you're curious about it. So that's it. And with this, we can correlate the certificates with CRT. We can, when we have all of these things and we have time, we can correlate more IOCs like domains, certificates with cert SH, DNS history, IP reputation, and even with census, you know. Census is a very good tool, and we can see a lot of things. And here is the things I already say to you guys. Soft-adder VPN. When we scroll down here, we can see OpenVPN and WinRM, one of their tools. We also can use the shutdown. Okay. Here, we can see what ports are open, what the servers inside it, and common vulnerabilities, and that's it. This way you can perform a good threat hunting, a good pivoting. We can also use like Joe sandbox, or even hybrid analysis to connect with a bad domain and see what happened. Okay, and that's a very good way to analyze some malicious domain without connecting with it. Even if you're on a VM, never connect to a malicious domain with your main machine, with your real host. Never do this. When we're creating some rules, when we're doing the detection engineer functions, um, it's good to create rules based on behavior and not only on IOCs. That's because we have something like parent of pain. Here, parent of pain show us what is easy to change, like hash values, IP address, domain names. So this, it's very easy to change, inside malware code. If you comment something short, your hash can be different. The IP address it's the same, it's easy to change, and some malicious and some command and controls use DGA to change the domains and domain names here, as I mentioned before. When we have IOCs collected late, often result in false positives. The same way, if we collect some fresh IOCs and keep it inside our database to create a detection rule based on IOCs, and can generate false positive too, because weeks later or even a month later, these IOCs cannot be used anymore, or there's other services with this IP. And the best way to create rules to don't be easily bypassed or easily generating false positives is to create detection rules based on behavior. So create some detection rules which detects registry keys used by persistence, detects behavior to lateral movement inside the environment. Create your rules based on behavior and TTPs, not only on IOCs. Okay, that's it, guys. I hope you can understand what I'm saying. I hope you can understand what I'm doing. And that's it, guys. Thanks for watching. Bye.